So up until now, we've been learning about the repository pattern in this series. The repository pattern gives us guidance when building a data access layer, or rather a persistence layer for our applications. There's one more pattern that you're going to see talked about at the same time as the repository, the unit of work pattern. So what is it? Well, Martin Fowler describes it on page 184 of his Patterns of Enterprise Application Architecture book, and also here at the URL you see on screen. He says that, first of all, it maintains a list of objects affected by a business transaction and coordinates the writing out of changes and the resolution of concurrency problems. He says in the next paragraph, when you're pulling data in and out of a database, it's important to keep track of what you've changed. Otherwise, the data won't be written back into the database. Similarly, you have to insert new objects you create and remove any objects that you delete. You can change the database with each change to your object model, but this can lead to lots of very small database calls, which ends up being very slow. Furthermore, it requires you to have a transaction open for the whole interaction, which is impractical if you have a business transaction that spans multiple requests. The situation is even worse if you need to keep track of the object that you've read so that you can avoid inconsistent reads. A unit of work keeps track of everything that you do during a business transaction that can affect the database. When you're done, it figures out everything that needs to be done to alter the database as a result of your work. So at a very high level, this has to do with bundling related changes to the data model. Some inserts, some updates, some deletes to data in related tables and executing those commands in the same transactional context. Now, before I move on, I just want to make sure that we're all on the same page with regards to the term transaction. In database parlance, a transaction is a special form of communication between your code and the relational database management system like SQL Server, that a collection of individual insert, update, and delete commands should only be committed to the database if all can do so successfully. If one of the insert, update, or delete commands that are in the context of the transaction fail, then the entire set of commands should fail. So the RDBMS, the Relational Database Management System, will then roll back the changes, meaning that it will undo any inserts, updates, and deletes that it may have already performed when it encounters one that fails. This functionality exists in order to keep the data consistent in the database, which is one of the large goals of an RDBMS in the first place. After all, if some inserts, updates, and deletes are committed and some are not for a given entity, then that entity will be invalid or inconsistent, and that's a huge concern when you're dealing with data. So for example, for a bank, it could mean that when I attempt to transfer $10,000 from my account to your account, and they attempt to create a $10,000 deposit in your account, but the debit on my account fails. Now we both have $10,000, which is great for us, but the bank won't be in business for very long if they don't fix that problem. Okay, so back to the definition of unit of work from Fowler. Specifically, he writes, a unit of work keeps track of everything you do during a business transaction that can affect the database. When you're done, it figures out everything that needs to be done to alter the database as a result of your work. So my first reaction when reading this, it describes some of the functionality seen in existing Microsoft data access technology. So in ADO.NET 2.0 years ago, and from that point onward, there was the data set, the data adapter, and so on. In the Entity Framework, there's the combination of the Entity Framework's self-tracking entities and the Entity Framework's DB command that kind of do this already. Unfortunately, however, in a multi-tier architecture that emphasized keeping the database access technology completely abstracted away from the domain layer to achieve a persistence ignorance between the two, then we lose the built-in features of self-tracking entities, or rather STEs. After all, when you yank the data out of the entity and you put it in a data transfer object and then you send it back up out of the persistence layer back into the domain layer, you're no longer working with entity objects, but rather simple data structures, the DTOs, the data transfer objects. And those have no built-in functionality at all, which is the point. So let's suppose that you subscribe to the repository per domain class approach that we talked about in a previous lesson, as opposed to the repository per aggregate root domain-driven design approach. The domain classes you're working with are, let's say, order, order item, and product. You're creating a new order for a customer, and in addition to creating the order and its associated order item instances, you need to decrease the number of products on hand in your warehouse. Your job as a programmer is to persist these domain class instances into the database so that the order fulfillment process can begin, and so on. So these three concepts are all associated in your domain model and in the relational database that will ultimately be used to save the data. However, how you persist each domain class to the database is up to you as the developer. If you treat them as independent operations, then you risk the possibility of one or more failures for the insert or update operations. You may have an order with order items. You may have an orphaned order item without a parent order, which is unlikely due to primary key relationships, but let's go ahead and just pretend like it's possible. Or you might have the product table's item on hand property would be incorrect. Most of these scenarios are not good. The only one you really want is just an order with order items, but it doesn't happen if one of the inserts fails. So in this case, the repository per domain class approach, the better option would be to treat these three operations as a single transaction, as a single unit of work. The various inserts and updates would all happen or they would all fail. If they fail, then you would be able to create some logic to help the end user resolve the issue somehow. At the very least, the data would not be in an inconsistent state. So in this case, the unit of work class sits atop the repositories by keeping a reference to each of the individual repository classes. Again, in this case, you have a one repository per domain class, right? So the unit of work class also has then a single save method, which would then coordinate with the various repositories to perform the various insert, update, and delete operations in the context of a single operation. I call it save. Other common names include save changes and commit and so on. All right, so if I were to explain this from a different perspective, take a look at this article, once again, implementing the repository and unit of work patterns in ASP.NET MVC application. So under creating the unit of work class, there we go. So near the bottom here, if you look on the right-hand side, it's about 70% of the way through the article. The author says the unit of work class serves one purpose: to make sure that when you use multiple repositories, they share a single database context. That way, when a unit of work is complete, you can call the save changes method on that instance of the context and be assured that all related changes will be coordinated. All that the class needs is a save method and a property for each repository. Each repository property returns a repository instance that's been instantiated using the same database context instance as the other repository instances. Okay, so let's take a look at a good example of this in the Testability and Entity Framework article. So if we scroll down to this section titled the unit of work pattern, and you take a look at this first example here of I unit of work. The author is using the I repository of T that we discussed earlier. That's fine. You could imagine any repository interface like the custom repository interfaces that I advocate used here instead. The next part is the interesting part, how you actually use the I unit of work interface in your application. First of all, notice that the I unit of work will have a reference to an I repository of employee, an I repository of order, and an I repository of customer, and then it'll also have a single method called commit. The next part is the interesting part. It's how you actually use the I unit of work interface in your application. So the first thing you do is create a concrete version of the I unit of work. So a concrete version of this. So the example in this article, let me see if I can find it here. It's nearer to the bottom, I think. Yes. So there actually there are two. There's one to be used to save into a SQL Server database called the SQL unit of work. All right, that implements I unit of work. And then there's another one called the in-memory unit of work that implements I unit of work. That's going to be used for unit testing. All right, but and unit testing, your persistence layer will be covered in another mini-series, as I've already said. So for now, what I want to do though is just examine this SQL unit of work implementation. And it has the following three features. First of all, notice that it holds a reference to the entity framework context that it instantiates in the constructor. So the object context was used in Entity Framework 4.0 and earlier. Definitely want to take note that you probably want to opt for the DB context in Entity Framework 4.1 and later. And this was written before that kind of came into play. That's another discussion entirely. Hopefully you get the idea here. The second feature is that it now holds a reference to each of the repositories. The article explains why the author chose to use I object set of T instead of I repository of T. Let's just pretend for now that it's using I repository of T or a custom repository interface. He chose to make it work with both the entity framework and unit testing, which is the point of the article. Let's keep it simple and just ignore that for now. And then the third thing I want you to notice is that it does have a commit method. The commit simply calls the database context save changes method. So the idea is this: the domain layer would act on each of the repositories in the domain layer classes, and it would interact with them like this little snippet of code that you see up here, right here. All right. Instead of working directly with each of the repositories now, the domain layer classes would work with the unit of work instance to get a reference to the given repository. So, and then the changes are made to the object set of T, which is working with the entity framework entities. And so then when the commit is called, those changes are committed to the database wrapped in a transaction. So keep in mind that a lot of the code is obviated because the author has allowed the entity framework to leak into the domain layer. That's not something I would be willing to commit to personally, but this was an article intended for the express purpose of showing how easy it is to unit test the entity framework. So naturally it's going to show a Microsoft tool-centric approach. Another implementation of the unit of work can be found in this article that you're familiar with. Implementing the repository and unit of work patterns in an ASP.NET MVC application, 9 of 10, right? Remember that, we've used it several times now. So if you scroll down about 70% of the way, you see there's this creating the unit of work class section. And so this example is returning I enumerables of entity framework classes, not POCO DTO objects or plain old CLR data transfer objects. So I'd have to deduct a few points for that. However, if you follow that example through to the usage of the unit of work class in the ASP.NET MVC controller action code, you would see that the client code in each of the controller actions looks something like this. Here, let me show you where I'm kind of talking about here. Yeah, this course controller class, and if you look throughout here, you'll see some examples of how it actually gets used. So you get this reference to the unit of work class, and then you use it throughout the body of all of the controller through the action methods. So for example, departments query equals unit of work dot departments repository dot get, and then it passes in, you know, that expression of func of tbool, right? And then also there's another example, course repository, unit of work dot course repository dot insert, given a new instance of course, and then unit of work dot save, which will actually then transactionally wrap up any classes or any multiple items that need to be saved all at the same time. Update does the same. Delete does the same, and so on. So in a sense, the unit of work class becomes the keeper of the repositories for the sake of transactions. To gain access to the repositories, you have to keep a reference to the unit of work class around. So there. Okay, so do you even need the unit of work pattern with a domain-driven design approach? Well, I prefaced the previous section earlier at the very outset with a qualifier. I said, let's suppose that you subscribe to the repository per domain class approach as opposed to a repository per aggregate root domain-driven design approach. In domain-driven design, you might go about this a little bit differently, as we talked about earlier. Instead of using one repository per domain class, and then using the unit of work class to kind of allow each of your repositories to share a single database context for the purpose of transactions. Instead of that, you use one repository per aggregate root. So to apply this to our previous example of order items, and product, the order would represent the aggregate root, at least in this context. Depending on the context and the desired features, the aggregate root might shift to another object in the group, like we talked about with earlier. Okay, the order has an aggregate of order items. The product has an association to order item. The order repository would then be responsible for the transaction context for the inserts, whether it be inserting an order or order items, and the update for changes to the quantity on hand in the product entity or table. And so the order repository would be responsible for the transactional context for these inserts and updates that need to happen. And this is the approach that I would prefer. All right. So to recap, you'll use the unit of work pattern to ensure that multiple repositories share a single database context for the purpose of a transactional commit. When you need to make sure that your entities have to be committed to the database or not committed to the database as an entire group together. All right. This is useful whenever you approach your persistence layer in a repository per domain class fashion, but not as useful when you're sticking with the domain-driven design approach, where you kind of get that baked into the repository in the first place. Hopefully that makes sense. All right, we're getting near the end. We'll see you in the next lesson. Thank you.